So we are dealing with question number 15 of modern physics. In a nuclear reaction, uranium-235 undergoes fission, liberating 200 megawatt of energy. The reactor has a 10% efficiency and produces 1000 megawatt power. If the reactor is to function for 10 years, find the total mass of uranium required. So over here we are going to calculate the weight of uranium required. So we begin with the formula for efficiency. So efficiency can be given as power output by power input. So efficiency can be written as power output by power input. And in here, the question is saying that the efficiency is 10%. So if the efficiency is 10%, so over here I can calculate the power input that is required, which is equal to power output by efficiency. So over here we can put the value of power output, which is equal to 1000 megawatt. So 1000 multiplied by 10 to the power 6 divided by the value of efficiency, where the value is 10%. So we can write it as 10 by 100. So from here we are calculating the value of power input, which is coming out to be 10 to the power 10 watt. Now energy required for this power can be calculated by simple calculation, that energy is equal to power into time. So if we do this calculation, I can say that power is equal to 10 to the power 10, and we have to do the calculation for 10 years. So for one day there are 86400 seconds. For 1 year there is 365 days, and we are dealing with 10 years straight. So we multiply this parameter with 10. So on calculation we end up getting a number like 3.1536 into 10 to the power 18 joule. So this is the energy requirement. Now if we come to the next part, we are saying that when a nuclear reaction of U-35 undergoes fission, it liberates 200 megawatt of energy. So over here I can say that one fission reaction is releasing 200 megawatt of energy. So from here I can do this calculation, that 200 megawatt means multiply by 10 to the power 6 multiply by 1.6 into 10 to the power minus 19 joule of energy is produced by one fission reaction. So by one fission reaction we get this energy equivalent. So therefore if the energy requirement is 3.1536 into 10 to the power 18 joule, then we will require how many fusion reaction. So from here we can calculate the number of fusion reaction that is required is 3.1536 into 10 to the power 18 divided by 200 into 1.6 into 10 to the power minus 13. So this is the amount of fission reaction that is required, and over here we end up getting a value of 0.985 into 10 to the power 29 fission reaction. So this is the amount of fission reaction that is required, 0.985 into 10 to the power 29 fission reaction. So with this it is clear that this is the amount of uranium atom that is required. So over here I can write that the amount of uranium atom required, amount of uranium-235 required, will come out to be 0.985 into 10 to the power 29 atoms. So now the question is of simple mole concept. So we can say that 6.023 into 10 to the power 23 atoms of uranium weighs 235 gram. So from here I can say that 0.985 into 10 to the power 29 atoms is going to weigh 235 into 0.985 into 10 to the power 29 divided by 6.023 into 10 to the power 23. So this is the value which will be obtained in gram. So in order to convert it into kg, we are dividing by 1000. So the answer will be in kilogram. So on solving, we obtain a value equal to 38451 kg. So 38451 kg is the correct answer for this particular problem. 38451 kg.